Have you ever looked up at the clouds and wondered about the power driving them? What if we could tap into those strong, consistent winds miles above our heads to power our world? For centuries we've used windmills and turbines, but they're limited by how high we can build. The real treasure trove of wind energy exists much higher up, beyond the reach of any tower. Imagine a system that soars like a bird, climbing thousands of feet to where the wind is strongest. This is the idea behind airborne wind energy, or AWE, a bold concept to capture the best wind on the planet. By developing advanced kites and autonomous drones, we might draw out clean, abundant power from the sky. The journey is complex, but the potential reward could change the world. So, how does airborne wind energy work? Imagine harnessing the power of the wind, not just from the ground, but from high up in the sky, where the winds are stronger and more consistent. This is the core idea behind airborne wind energy, capturing energy from altitudes that traditional wind turbines simply can't reach. Instead of a massive tower and spinning blades, these systems use a tethered flying device, like a kite or a drone, connected to a ground station. These devices soar hundreds of meters above the Earth, where the wind is both faster and more reliable. There are two main methods for generating electricity with airborne wind energy, each with its own unique approach and technology. The first method works like this. The kite or drone flies in a controlled looping or circular pattern, pulling a tether that unwinds from a drum on the ground. As the tether is pulled out, it spins the drum, which in turn drives a generator to produce electricity. Once the tether is fully extended, the system automatically reels it back in, using only a small portion of the energy it just generated. This cycle of unwinding and rewinding repeats over and over, creating a continuous supply of power. The second method is a bit different. Here the flying device is equipped with small turbines mounted on its wings. As it glides through the air, these turbines spin and generate electricity, which is then sent down the tether to the ground station in real time. This approach allows for continuous power generation, as long as the device remains airborne and the wind keeps blowing, making it highly efficient in the right conditions. Both methods represent a radical new way to think about wind power, untethered from the ground, reaching higher, and capturing more energy than ever before. It's a leap forward in renewable technology. The engineering behind these systems is clever and innovative, but the principle is simple. Go where the wind is best. By tapping into high-altitude winds, we can unlock a vast, previously inaccessible source of clean energy. Airborne wind energy could transform how we generate clean electricity, making renewable power more accessible and efficient for communities around the world. It's a new chapter in renewable energy, one that's just beginning to take flight. Across the globe, several pioneering companies are racing to make airborne wind energy a reality, pushing the boundaries of what's possible in renewable power. These innovators are not just dreaming, they're building, testing, and flying their creations, determined to harness the powerful winds high above us. Makani Power, once backed by Google, built a remarkable large drone with turbines on its wings. This airborne machine flew in giant circles, generating electricity as it soared, and sent that power down a tether to the ground. Their vision was to capture stronger, steadier winds at higher altitudes, where traditional wind turbines can't reach. Meanwhile, Italian company KiteGen uses massive kites that sweep across the sky in crosswind patterns, pulling cables connected to ground-based generators. They imagine entire kite farms, with fleets of these powerful kites working together, producing clean energy on a scale that could rival conventional power plants. In Germany, SkySails Power adapted their ship-pulling kites for land-based electricity generation. Their steerable, parachute-like kites fly in precise figure-8 patterns, pulling tethers attached to mobile ground stations. This innovative approach allows for flexible deployment and efficient energy capture even in remote locations. These innovators have proven that airborne wind energy is more than just a concept. Each company brings unique designs, creative engineering, and valuable research to the table, moving the field forward with every test flight and prototype. Their shared goal is ambitious yet inspiring: to unlock the vast, untapped energy found in high-altitude winds, which blow stronger and more consistently than those near the ground. The field is advancing rapidly, with each breakthrough and successful demonstration bringing us closer to a new era of wind power, one that could transform how we generate clean energy worldwide. The sky is no longer the limit for these visionaries, it's the opportunity, a vast frontier, waiting to be explored and harnessed for the benefit of all. These trailblazers are redefining what's possible in renewable energy, inspiring a new generation of engineers and scientists to look upward for solutions. Sometimes, the best solutions really do come from above, reminding us that innovation often takes flight where we least expect it. Why send kites or drones thousands of feet up into the sky? What's the real benefit of reaching such incredible heights with our technology? The answer is simple: that's where the best wind is found. Up high, the wind is not only stronger, but it's also much more consistent and reliable than what we experience closer to the ground. Near the ground, wind is constantly interrupted and slowed down by obstacles like trees, hills, and buildings. This makes it unpredictable and often too weak for efficient energy generation. But higher up, above these obstacles, the wind flows smoothly and steadily. It's stronger, less turbulent, and far more reliable for generating power. Here's the exciting part: the power in wind increases with the cube of its speed. That means if you double the wind speed, you actually get 8 times more energy. So, even a small increase in altitude can make a huge difference. Airborne wind energy systems operating at 500 meters or more can tap into these powerful winds, accessing far more energy than traditional ground-based turbines ever could. Traditional turbines are limited by how tall their towers can be, which is restricted by engineering challenges and high costs. Airborne systems, on the other hand, can simply let out more tether to reach higher altitudes. High-altitude wind isn't just stronger, it's also much more consistent, blowing steadily both day and night, regardless of weather changes on the ground. This means airborne wind systems can generate energy around the clock, providing a more reliable and predictable source of renewable power. By harnessing these high-altitude winds, airborne wind energy could dramatically boost both the capacity and reliability of wind power worldwide. It's a true game-changer for the future of clean, sustainable energy, opening up new possibilities for how we power our world. The higher we go, the more energy we can capture, making our renewable energy systems more efficient and effective. That's the real advantage of airborne wind, unlocking the vast, untapped power of the skies above us. Traditional wind turbines are massive, requiring tons of steel and concrete. Airborne wind systems flip this model. Only the kite or drone needs to fly, while heavy equipment stays on the ground. This can reduce material use by up to 90% compared to conventional turbines. Less material means lower costs and easier transport. Many airborne systems fit inside a shipping container and can be deployed almost anywhere. No need for giant cranes or deep foundations, just set up and launch. This flexibility opens up wind power for remote, hard-to-reach or temporary locations. Airborne wind systems can bring clean energy to places traditional turbines can't reach. Their adaptability is a powerful argument for the technology. The future of wind power could be lighter, cheaper, and more mobile than ever before. Makani Power's journey shows both the promise and challenge of airborne wind. Backed by Google, Makani built a 20-ton energy kite that could power hundreds of homes. The technology worked, but making it economically competitive proved tough as traditional wind costs fell. In 2020, Sinan son frigidingens, mites. Makani was shut down. Not for technical failure, but for business reasons. Yet, Makani's legacy lives on. Alphabet released all its patents and research to the public. Their decade of work became a foundation for others in the field. Companies like SkySails and KiteGen are building on Makani's knowledge, pushing the technology forward. Makani's story is a reminder. Innovation is a marathon, not a sprint. Even setbacks can move the whole field ahead. The dream of airborne wind energy is still very much alive. The strongest, most consistent winds are often found at sea, but offshore wind farms are expensive and complex to build. Massive foundations, deep water, and harsh conditions drive up costs and make maintenance difficult. Airborne wind systems could change the game. Imagine floating platforms or ships equipped with energy kites. These platforms need smaller anchors and can be moved or towed for repairs, reducing costs and complexity. Airborne systems could unlock deep-water wind resources far from shore, where the wind is best. Maintenance becomes easier and cheaper, and the technology is more flexible. Combining airborne tech with offshore wind could make clean energy more affordable and accessible. The ocean could become a vast, new source of renewable power. Airborne wind might be the key to truly harnessing offshore wind's potential. Airborne wind energy promises cheaper, more accessible renewable power. By using less material and skipping massive towers, these systems could dramatically lower costs. Their small footprint means less land disruption and a smaller carbon impact. Mobility is a huge plus. Airborne systems can be deployed quickly for disaster relief or in remote areas. They could bring clean energy to places that rely on expensive, polluting fuels. This technology could transform developing economies and help fight climate change. Challenges remain. Safety, reliability, and airspace regulations must be addressed, but these are solvable with research and investment. The potential for cheaper, greener, and more flexible energy is too great to ignore. Airborne wind energy could help power a sustainable future. Will we soon see fleets of energy kites and drones powering our world from above? The future is still unwritten. The technology is promising and the physics are sound. Setbacks like Makani's are part of the journey, but progress continues. The key question: can airborne wind compete economically with other energy sources? With rising demand for clean power, the world needs bold solutions. Airborne wind energy could be a crucial piece of the puzzle. The sky isn't the limit, it's our next great resource.